All right, this is the second part of our pre-calculus practice test. What test number is this? This is test number 3 for the practice test. All right, jumping straight into number 21 where we left off. We're going to be using a calculator for these, but you need to set them up. So right now, I always think of Rapunzel being trapped up here. The only way to untrap Rapunzel, who's stuck in this tower of 11, is to bring Rapunzel down with the power of a logarithm. Right now, this exponential is by itself, which means we are ready to take the logarithm of both sides. So I'm going to take the log of the left, and that's going to be equal to log of the right. We can choose any base that we want. Typically, we choose the base that is the base of the exponential, meaning we have log base 11, log base 11. That means we have a negative 9m and an 8 on the inside. I don't know why I said that. It's 11 to the power of negative 9m and 8. There we go. And from there, things that cancel out, log 11 base 11, and I'm left with a negative 9m, and that's going to be equal to log base 11 of 8, but this is going to be a change of base formula because we can't put that into our calculator. So this is really log of 8, all of this divided by log of 11. And now that we've done our change of base formula, we just divide by 9. We say divide by 9, negative 9, divide by negative 9, and I get m by itself is equal to this. M is equal to, I'm just going to type this into a calculator real quick. So let's go split view, split with a scientific calculator. And I need to type in, let's see, function logarithm of an 8, and that's going to be divided by, there's a negative 9, and then we have a logarithm of 11. And that seems like a weird number, but I'm going to go ahead and assume it's correct. Give me some more room to write. Negative 0.0, what are we rounding to? Round your answers to the nearest 10,000th. That's 4 decimal places. 4 decimals. So I have 0.9, which is 2 decimals, and then 6.3, but that 3 is rounded up because of the 5 that follows it, so it's going to be 6.4. And we're good. All right, so then we move on to, well, I guess I should be checking my answers. Those seem really weird. 0.964 for number 21. For number 21, 0.964. Okay, I guess I'm getting them right. I was scared there. Number 28. Again, we need to isolate this exponential, so we need to get rid of this times by 2.8. So I'm going to divide both sides by 2.8. Divide by 2.8. Divide by 2.8. That's going to give us 17 to the power of x minus 3, and that's going to be equal to 11 over 2.8. I don't want to do any math until the very end, any calculator math until the very end. Now I can take the logarithm of both sides to untrap Rapunzel out of her tower, and I can get, I want to write it with pen though. This is going to be log base 17 to match the base of 17 to the power of x minus 3, and that's going to be equal to log with the same base. The left and right have to be the same base, and this is going to be in parentheses 11 over 2.8. That's 2.8, not 2 times 8 if you're misreading my terrible handwriting. From here, things are going to cancel. You're gone, you're gone, you're gone, leaving us with an x minus 3, and that's going to be equal to all of this stuff, which is going to be a change of base formula. So on the top of my change of base is the log of that fraction, which is 11 over 2.8. And on the bottom of the fraction, it's going to be log of the base, which in this case is 17. And then from here, we just add 3 and add 3. And from there, x is going to be equal to all that stuff right there, which I'm going to type in the calculator right now. So calculator, come on open. And we've got, type in logarithm of 11 divided by 2.8, and then that's all going to be divided by logarithm of 17, and then I need to add 3 at the very end. So 3.48, 3.48, 2 more decimals, 2.9, and the 9 doesn't get rounded up because it's followed by 4. Looks pretty good to me. And have I been boxing my work? Did I box my last one? Oops, I'll box that one as well. All right, after 22 comes number 23. And again, we're trying to isolate this exponential, so this minus 10 has got to go. We're going to add 10 to both sides, add 10 to both sides. That gives me 19 to the power of 8r minus 1 is equal to 25. And then from there, we are going to untrap Rapunzel. We're going to save Rapunzel by taking the logarithm of both sides. We're going to take the log of the same base of our exponential, which is base 19, of that whole thing, 19 to the power of 8r minus 1. And this is going to be equal to the logarithm of the same base 19, of 25. And then from here, I'm going to cancel some things. You're gone, you're gone, you're gone, leaving me with an 8r minus 18 is equal to, and change the base formula over here. This is going to be log of 25 in the numerator. The denominator is going to be log of 19. And I got to do some things. I'm going to add 18 first, and then after I add 18, then I'm going to divide by 8, then I'm going to divide by 8, which means r is equal to all of that. I'm going to enter it all into the calculator at the same time. I'm typically lazy and I do the calculations until, I save them until the very end. They're kind of like dessert in that way, right? Or do you not save dessert like I do? Here we go. This is going to be log of 25, and that's going to be divided by log of 19. And then I do plus 18, and pro tip, now I end my parentheses, which means it starts the parentheses, and then I can divide that entire thing by 8, and I get about 2, in pen please, 2.386, and then that 6 rounds up to a 7 because of the 5 that follows it. And I think I have my answer, which I will then box. Hopefully that's correct. Okay, let's check. 2.3867. 2.3867. I don't see that number. It should be in this vicinity. I've made a mistake. What is my mistake? Well, let's check the last one. 3.4829. 3.4829. I got that one right. Okay, so I've made a mistake over here. Number 23's actual answer should be 0.2617. 0.2617, and then now you get to see me problem solve. I made a mistake in here. I'm supposed to get 0.2617. I'll erase that in a sec. That's what I'm trying to get so I can remember. What did we get? Just checking our work. Adding 10, we got 25. We took the logarithm with base 19. Base 19 is down there, 25, and we need to. Oh, Mike, and there it is. Do you see the mistake? It went. I guess it's from here to here. There's the mistake. If you caught the mistake before I did, give yourself some extra credit. Hopefully you pause the video. That means I just have to do this. I can erase the 8, erase the 8, erase the 8, erase the 8, and I think it's all now fixed, except this number is probably going to have to be erased as well. Yeah, that looks good. -1, -1, -1, -1. We have to add 1 to both sides, and okay, let's try this again. The one time I actually check my work, I make a mistake. Maybe I've been making lots of mistakes. I just changed this 18 to a +1 and 0.2617. Let's go. Okay. 0.2, my pen. 26. Oh, there's a decimal in here somewhere. 0.2617. Calculator go away. I can erase the answer that I was looking for. Make sure you're checking your work, everyone. I'm not the best example in this video, am I? Number 24. We're solving this, okay? So we need to undo a logarithm. The way that we undo a logarithm is with exponentiation. So I'm going to say, and by the way, the parentheses here are weird, but the parentheses are technically right here. I'm going to undo exponentiation by taking everything 5 to this power, or 5 to this side. So 5 to the power up, and I rewrite log base 5 of -2x, and that's going to be equal to 5 to the power of 3. Again, these became the new powers, right? That's a power, that's a power. And what's supposed to happen here is cancel, cancel. Oop, I want to change it to a different color so it pops out. Cancel, cancel, cancel. And I have now -2x is equal to 5 to the power of 3, which I guess I can just say is 125. And then finally divide both sides by -2, and x is equal to -125 over 2. And do we need to have decimals? Or is that going to be 62.5 with a negative symbol outside? I think either way. I'm curious what the answer key does. Number 24, -62.5. Number 24, no, they leave it as a fraction. Fractions are better. All right. Number 25, kind of the same thing. We need to isolate the logarithm, though. There's the logarithm. You don't belong. We have to add 8 to both sides to get us started. +8, +8, which means I have this log base 2 of n minus 10. That's going to be equal to 2. And now it's time to undo the logarithm. So I'm going to change. I'm going to do exponentiation with a 2, and I'm going to be lazy here. I'm just going to say 2 right here and 2 right here. You know, got to move that equal sign down so it actually looks like an equation. And there it is. So I did exponentiation with the 2's, and now that means things are going to cancel. You're gone, you're gone, you're gone. And I now have n minus 10 is equal to 2 to the power of 2, which is 4. Add 10 to both sides, n is equal to 14. Pretty sure that's the right answer. Let's go to just check our work. 25. Let's be a good example. 14. I think that's what I said. Did I say 14? I said 14. Yay. All right, number 26. Again, we need to isolate that logarithm, which means you, -7, need to move. We need to add 7 to both sides. Add 7, and I now have log base 6 of 9m minus 2 is equal to 2. And time for the exponentiation, so I'm going to do a base of 6 for exponentiation. 6, 6, and we'll move our equal to sign down so it looks like a nice equation. And things that cancel out, you're gone, you're gone, you're gone, leaving me with a 9m minus 2 on the left. On the right, 6 to the power of 2 is 36. And I just have to add 2, so that's going to be 9m is equal to 38. And then finally divide by 9, and m is equal to 38 over 9, which I don't think has any common factors. I'm just going to leave it 38 over 9. Let's check the work. Number 26, 38 over 9. 26, 38 over 9. We're doing something right. All right, moving on to number 27. Last problem on this page. We got some natural logarithms, which remember, if you've forgotten, natural logarithm is the same thing as log base e. So in this case, I need to probably somehow combine these into one logarithm so I can undo it. Right now I can't undo it when they're separate like this. Remember, if the outsides are being subtracted, the insides are being divided by. So this is going to be really x divided by 4 for the insides. And I still have a natural log out front. Over here, the right side doesn't change. Now I can undo this logarithm by exponentiating it. And remember, the natural log over here is the same thing as base e, so I'm going to choose a base e. E to this, or exponentiation from the e, and e, and things that'll cancel out. When I do that, you're gone, and I get x over 4, and that's going to be equal to e squared. And finally, we multiply both sides by 4, and x is equal to 4e squared. Final answer, box it, check our work, 4e squared for number 27, 4e squared for number 27. There we go. Number 28. We're on to this next page. Again, kind of the same thing. If we have the outsides are being subtracted, the insides are being divided. If we had, dang, I didn't do any plus sign on the practice quiz. Well, on the test. On the actual test, you might have a plus sign. A plus sign means you would multiply the insides, which means you'd probably have to distribute the 5 into these. But we are doing division, again, 3 times. This is probably a bad practice quiz. I might fix that in future years. This is going to be log base 2, and then on the insides, they're not being subtracted, they're being divided. I have x plus 1 divided by 5, and that's going to be equal to 5. Time to undo the logarithm with exponentiation, namely 2, and a 2 right here. We'll move the equal to sign down to make it look like an equation, and we're going to cancel some things out. You're gone, you're gone, you're gone, leaving me with x plus 1 over 5 is equal to 2 to the power of 5, which is 64, I forget. 2 to the power of 3 is 8. 4 would be 16, so 32. And multiply both sides by 5. That's going to be 160, I think, over there, and x plus 1 over here. Subtract 1, and x is equal to 159. Maybe, he said questioningly in his voice. 28, 159. 28, 159. Yay, let's go. All right. Number 29, again, if this was a plus sign, I would multiply, but it's a minus, so we divide the insides. This is going to be log base 7 of x minus 2 all over, I don't know why there's a parenthesis right there, x minus 2 all over x minus 4, and that's going to be equal to 1. Right side doesn't change. All right, time to exponentiate, meaning I have a 7 and a 7. Move the equal to sign down so it looks like an equation, and cross some things out. You're gone, you're gone, you're gone, with a different color, of course. You're gone, you're gone, you're gone. So I have x minus 2 over x minus 4 is equal to 7. Multiply both sides by x minus 4, and I get x minus 2 is equal to, distribute the 7, and I get 7x, distribute the 7, negative 28. Again, just showing my work, I guess I did that operation for cross multiplication. And from there I add 2, let's move the x's to the right, and I'm going to get 6x on the right. Move the 28 to the left, and I get 26 on the left. Divide both sides by 6, and I get x is equal to 26 over 6, which is the same thing as 13 over 3, which I believe is going to be my final answer. 13 over 3 for 29. 29, 13 over 3, please, please, please. There it is, 13 over 3. And it looks like the answer to the next one is a graphing, and we indeed get some graphs. So again, this is very similar to the first few problems of this practice test, where you have to graph the exponential, and then you kind of flip it over this line, y equals x right here. So if I have a point right here, you reflect it and it becomes a point over here, or it's easier to do on a table. So let me give you the inverse. So I'm going to try to find the inverse. Let's pretend that this is I'm going to scroll you out. You're a y. So if I have, and I'm going to switch them now, x is equal to log base 5 of not x but y plus 3. I'm making the Sindel mistake where I forget to switch my x to my y. Now I'm going to solve. I'm going to exponentiate, so I have 5 to this power, 5 to this power, and I guess I can move this equal to sign down so it looks like an equation. Things will cancel out, right? We'll say gone, 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 and I have y plus 3 over here, and this is going to be 5 to the power of x over here. Finally, we subtract 3, and this is going to be 5 to the power of x minus 3 is going to be equal to y, which is really the inverse function. So I'm going to graph the inverse. Or I'm going to make a table for the inverse, and then I'm going to switch them real quick. So the inverse is going to have an input, it's going to have an output. Let's see what values we can get here. So there's my table. I'm trying to choose nice values. 0 is almost always a good value. If you can somehow make this power 0, that's usually where I start. So let's go ahead and start with 0. If I plug in 0, and I'm going to do some mental math here. I should show my work on the first one, then I'll do mental math from there. It's going to be 5 to the power of 0 minus 3, which is going to be 1 minus 3, which is going to be negative 2. From here, you can do mental math. If I plug in 1, 5 to the power of 1 is 5. 5 minus 3 is 2, and I get an output of 2. What happens if I do a 2? 5 to the power of 2 is 25. 25 minus 3 is 22. And it explodes really, really quick. And that goes off the graph. So we can't really go that far. Do I have any more points that I can put on here? Because 2 points is typically not enough. It's because I chose such a big number right here. If I chose a 3, it would stay on the graph. Might as well go to -1, I suppose. It's kind of out of order. Let me go ahead and yoink you guys down here, yoink you guys down here. And what if I do a -1? So if I plug in a -1, 5 to the power of -1 is going to flip it, and it's going to be 1/5. 1/5 minus 3 is gross. It's going to be, can I go to decimals? No, fractions are better. 1/5 minus 3 is -2 4/5, which is, well, not approximately, it is exactly equal to -2.8 if I'm trying to graph this thing. All right, so I have my inverse, and then this is going to be the non-inverse, or this is going, what's the opposite of inverse? It's just the normal function, I suppose. So this is the function. For the function, I have an x and I have a y, and I just switch the numbers, right? So u and u switch, so I have a -2.8 and then a -1. I have a -2 and then 2. I have a 2 and then a 1, and I have a 22 and then a 2. Something's off. This is supposed to be a 0. That's why. My bad, my bad. So let's change that to a 0 and keep this as a 2. All right, because these are now -1, 0, 1, 2, and those all match this side. Okay, everything's looking good. So time to graph our actual function. Again, the entire process looks like this. Take the inverse, make a table for the inverse, and then go back to the normal function. Again, taking the inverse is the same thing as switching your x and your y values. So let's graph here. I have -2.8 comma -1, -2.8 comma -1 is right about there, I'm thinking. What about -2, 0? So -2, 0 is right here. And then 2, 1 is going to be 2, 1 goes right there. And then 22, 2 is off the graph. All right. Where is my it's now a vertical asymptote instead of a horizontal asymptote. I'll annotate this too. When I have this +3, this means go left 3 for my vertical asymptote, and you can see -3 is right here, meaning that I have this electric fence with this dashed line that I'm making, which is, in terms of a drawing, it's kind of like a magnet, which means I have, I'll do black line. The line goes through those points and then comes down and kind of stays on top of the asymptote, and then up here it shoots off into, well, that's kind of some bad lines right there. But it does shoot off, well, even worse, shoots off this way forever. I'll eventually hit this height of 2 once I go all the way out to 22. So that's all I can do. In this case, if I were looking at this problem, I'm not going to make such a bad problem with such a big number. I'm going to make it so that you can get 3 nice values. I had to have 3 values here, so I had to get some weird decimal number. But on the test, I'll actually make them nice. What about number 31? Same process as before. We'll take the inverse, make a table, and then switch the table to get back to the normal function. So taking the inverse, I'm going to say that this is x is equal to log base 2 of y minus 3, avoiding the Sindel mistake of forgetting to switch your x and your y's. I'm going to add 5 to get x plus 5 is equal to log base 2 of y minus 3. And then I'm going to exponentiate. So I have 2 to the power of that is equal to 2 to the power of that. We will move the equal to sign down so it looks nice. And that will cancel some things out, meaning we have y minus 3 on this side, and we have 2 to the power of x plus 5 on this side. And from here, I'm going to say 2 to the power of x plus 5 after we add 3 to it will be our y. So it's time to make a table. Our table is going to be values of x, values of y. Let's see what we get. So if I choose, again, I kind of want to make this thing 0 to start us off. That would be nice. To make this 0, I'm going to start with an input of -5. If I start with -5, that's going to be -5 plus 5, which is 0. 2 to the power of 0 is 1, and 1 plus 3 is 4. So we'll say my output is 4. And then what do I want to do? Well, I don't want to flip this. It's a nice number, so I'm going to make these positive. So I'm going to go up a little bit. Up from 5, we'll go to -4. And check it out. -4 plus 5 is 1. So this power up here is 1. 2 to the power of 1 is 2, and 2 plus 3 is 5. And then from there, what happens next? I'm going to go to -3, do some mental math. -3 being plugged in here is going to be 2 up here. 2 to the power of 2 is 4. 4 plus 3 is 7. I get 7. I have 3 nice points, and I think the next one is going to be off the graph since this graph goes to 8 in both directions, so 7 is really close to 8. I think the next one is going to be off the graph. So from there, just as a reminder, this was, and I should mark it up for you guys, this was the inverse. And now I'm going to flip them yet again, and I'm going to come to my precision eraser so I can get rid of that line a little bit and go back to stroke eraser. And now I'm going to do the actual function. So the function is just going to switch the x and y values, just like we did in the last case. So instead of having 4, 5, 7 over here, 4, 5, 7 is going to live over here. 4, 5, 7. And instead of having -5, -4, -3 over here, they're going to live over here. I'm going to have -5, -4, -3. And then I graph these x and y coordinates. 4, -5, 4, -5, and 5, -4, 5, -4, and 7, -3. 7, -3. And then last, I need to look at my asymptote. Again, I have a -3. Did I have a -3 in the other one? I had a +3. So this is the opposite. Instead of going left 3, this is going to be right 3. So that means I have this asymptote right here at +3. It's always a vertical asymptote when you're talking about logarithm functions. And in terms of in mathematics, it gets closer and closer to the line without actually touching, but because our artwork is imprecise, our graph is going to shoot out this way, but it's going to get closer and closer to this line and eventually kind of look like it's on top of it. There's our graph for 31. On to, I was about to go to the next page. 32 is down here. Same thing as before, find the inverse, make a table, switch the table. So inverse, we're going to have x is equal to log base 1/3. Ooh, we have a fraction this time. And this is going to be not y, but, or sorry, not x, but y plus 6, and then -5. Again, this -5 has got to go to this side, so I have an x plus 5 is equal to log base 1/3 of y plus 6. And then from there, I'm going to exponentiate by using this base of 1/3. So I'm going to have 1/3, and maybe I'll make it a little bit bigger. 1/3. There it is. 1/3, the power of all of that stuff. I'll move this equal to sign down so you can see my work. And then you're gone, you're gone, you're gone. Leaving me with 1/3 to the power of x plus 5 is equal to y plus 6. And then I just subtract 6 and I get my y by itself. So y by itself is 1/3, all of that to the power of x plus 5, and then we had to minus 6. Time to make the inverse table. So the inverse table is going to have an input, it's going to have an output, and then we're going to have the actual function over here, which is going to have an input and it's going to have an output. So the actual inverse, again, I'm trying to make this power 0 because that's a nice number. To make it 0, I'm going to have to plug in -5. So I'm going to plug in -5. When I do that, -5 plus 5 is 0. Anything to the power of 0 is 1. 1 minus 6 is -5. Interesting that the input and output are the same thing. Just happened chance. It didn't, just random, right? Okay, now here's the question. Do I want this power to be positive or negative? And the answer is negative, because if this is negative, it's going to flip the fraction and it's not going to be a fraction anymore. It's just going to be 3. It'll be nice. So let's make this even more negative. More negative means I'm going to -6. If I go to -6, -6 plus 5 is -1. -1 means just flip the fraction and keep the power the same as the power of 1. So flipping the fraction gives us 3. 3 minus 6 is -3. And finally, let's go a little bit more negative. Notice what happens when I plug in -7. -7 plus 5 is -2, which means flip this and take it to the power of +2. Flipping this is 3, to the power of 2 is 9. 9 minus 6 is a +3. And those are 3 points. That's enough. So let's go ahead and switch. Again, switching. You live over here. You live over here. Here we go. -5, -3, 3, -5, -6, -7. And I graph these and look at the vertical asymptote, and we're done with this problem. So -5, -5, we go -5, -5. Then we go -6, -3, -6, -3, and -7, -3. So we go -7, no, -7, +3. I was like, that's on the same point. Okay, -7, -7, +3, -7, +3. And this is an interesting function. So it's going to get, where's the asymptote here? What? I have made a mistake. -6. Something weird is happening here, because you always have a vertical asymptote, and I know where that vertical asymptote is, because this here says left 6, which means my vertical asymptote, no matter what I do, is going to be right here. And the problem with these points that I've drawn, my vertical asymptote is right in the middle of my function, which cannot happen. So I've made a mistake. Let's go ahead and find that mistake. What happened here? Did I copy down the problem correct? +6 minus 5, base 1/3. Everything looks good there. I added 5. I exponentiated with 1/3. I subtracted 6. I don't see the mistake there. Was it a mistake with the mental math? I guess we'll find out. So in theory, when I plugged in, I was redoing that again in my head. There has to be a mistake up there. Okay, it has to be down here then. If I plug in -5, that's going to be 0. 0 is going to make this 1. 1 to the power of 0 is, or sorry, anything to the power of 0 is 1. 1 minus 6 is -5. That works out, and that point isn't the issue. That point is the issue. So what happens if I plug in -6? -6 seems like a nice value. When I plug in -6, that's going to be -1. It's going to flip this, become 3. 3 minus 6 is -3. I don't see my mistake. Oh my goodness, I see my mistake now. I don't know how to graph points. If you found the mistake before I did because you paused the video, good for you. You get extra credit. Let's actually graph these correct, yeah? -3, -6 is, here, let's erase you blue point, -3, -6 lives right there. I just had a brain fart. It happens. I'm glad I caught it. And then 3, -7 is going to be 3, and then -7 is going to be down here. There we go. This makes sense because we're not intersecting our asymptote. So in theory, we are going to have a line that gets closer and closer to this asymptote, and it comes down through these points like so. There we go. There's our graph. Whew. On to number 33. Okay, all of these. These are pretty straightforward calculator questions. Just know the difference between when it says continuous versus when it says compounded 6 times. If it's a number of times, it's a little bit harder of a formula. This is an easier formula. I'll just write it once. The end is equal to the start times e to the power of, it's going to be like interest rate times time. So I'm going to say r times t. Good enough. So our start amount is 1,565. So I'll come down here and say 1,565 is our start amount times e to the power of our interest rate is 6%. So it's going to be 0.06. And our time is going to be 9. So that's going to be times 9. It's asking the account balance after 9 years. It's asking for the end amount. It's asking us to solve for that, which means plug that into the calculator. Let's do it. So I have 1,565 times, I need a letter, e to the power of 0.06 times, oh, the times is going to have to be stuck up here. So I'm going to have to do parentheses here to keep it up here, and times 9. And I get this number, which is I should put in pen, 2,000, $685.55. That's a money amount, so let's see if that's right. 2685, 2685, 55, 2685, 55. There we go. We're on to number 34. Here we go. It's going to be the same type of formula, so I'm not going to rewrite it. It's what it is over there. It has the end amount here, so let's start with that. It's going to be 15262.17. It's going to be equal to the start amount, which we do have, 8894, times e to the power of interest rate, which we don't know, so I'm going to call R, and times time, which is 9 years. And we're going to solve for R. So the way that we do that is I can first get rid of this 8894 by dividing by it, right? So I'm going to say divide both sides by 8894, divide by 8894, and that's going to give me just e to the power of 9r is equal to, do I have to rewrite it again? Okay, 15262.17 all over 8894. And then from here, we have to untrap Rapunzel, literally an R on the top for Rapunzel, by taking the logarithm. I'm getting really lazy here, so I'm going to just move you and actually do the logarithm right now. I'm going to say logarithm on this side, logarithm on this side, and what base do we choose? Whatever that base is. So we're going to say log base e, and things are going to cancel. You're gone, you're gone, you're gone, leaving me with 9r is equal to all of that, which I'm getting super lazy about. Wow, I don't know what's going on. Just don't want to copy, and if my technology would work, 9r is equal to all of that, which means my final step is to divide everything by 9, divide that whole thing by 9, and r is going to be equal to whatever that is on the calculator. And remember, log base e is the same thing as natural log, so I don't have to do a change of base formula. Calculator, please help me out. Calculator, go. I have, I'm going to start by typing in a natural log, 15262.17, and that's on the inside divided by 8894, and that whole quantity is divided by 9. And I get 0.006 with a lot of zeros, so r is equal to, thank you calculator, 0.06, which as an interest rate is 6%, so I can come over here and say 6%, final answer, box it. Nice. Number 35, again, same word continuously, so same exact formula. I'm going to leave the formula up there so you can see it. I still want to be able to have room. There we go. So the end amount we do know is going to be, where is it? It's going to be 5078.17. It's going to be equal to the start amount, which we also have, 3762, and that's going to be times e to the power of rate, which is 0.03, and we don't know the time, so it's going to be t. So again, kind of the same thing. We need to divide both sides by 3762, divide both sides by 3762, and now I get the e by itself. I have this e to the power of 0.03t, and that's going to be equal to 5078.17 over 3762. From here, we're going to untrap Rapunzel, and again, I'm going to do that all in one step by moving you over and writing log base e, and things will cancel. You're gone, you're gone, you're gone, leaving me with 0.03t is equal to, let's do a little copy paste. Let's see how fast I'm getting at that. Copy and paste is equal to that thing. And then from there, I'm just going to divide everything by 0.03, divide by 0.03, and t is going to be equal to whatever that is on the calculator. So calculator, let's open you back up. And we're going to get, make sure I can see the whole thing. We're going to get the natural logarithm, and then it's going to be a fraction here, 5078.17 divided by 3762, and that all is divided by 0.03, and I got 10 on the dot. So 10 years, 10 years. Box it. Everything is in years in these problems, so I didn't even look at the unit. All right. Number 36, now it's compounded 6 times, which means we have a slightly different formula. Our formula now is going to be end is equal to start times 1 plus the interest rate, which I'm going to keep as r, all over the number of times that you compound to the power of number of times that you compound. Again, these are the same number, and I still need to multiply by t, so n times t. Cool. So what do we have here? We have no end amount because it's asking for the end amount. So you're blank, and the right-hand side is going to be, oh, there is an end amount. I'm sorry. It says after 15 years, there's the end amount. So it's going to be 4657.16. My equal to sign is a little bit too low, or maybe you're too high. Okay, there we go. And that's going to be equal to the start, which we don't know, so I'm just call that x. I don't want to do s because it looks like my 5s. This is going to be 1 plus the interest rate, which is 0.04 from 4%, divided by 6 times per year to the power of 6 times per year times 15 years. And the cool thing about all of that is it's just a number, like 7. So if I just divide by that number, I'm done. So here's how I'm going to show that in my work. I'm going to say, I'm going to grab all of you. I'm going to copy and paste, and I'm going to say divided by all of you. Ooh, can I paste again? Oh man, so nice. Check it out. I'm going to say divided by that, you're gone, and x is equal to, just need to type you into the calculator. So, calculator, ayúdame, ready, set. We've got a 4657.16 divided by, I just need some parentheses here, parentheses, 1 plus 0.04 divided by 6. Got to end the parentheses down here, and this can be to the power of, start the parentheses for our power, 6 times 15. And I get, rounding to the nearest cent here, this is going to be 2, in pen please, $2,561. And I can make my boxes correct. There we go. And on to the next one. Same formula. If you missed the formula, go look at it above. We know the start amount and we know the end amount. The end amount is 7697.01. The start amount is 6828. It's going to be times 1 plus, do we have any interest rate? Don't have the interest rate. R over number of times we compound, 6 to the power of 6 times time, and time is also 6. Okay. So, first, let's get rid of u. Let's divide by 6828, divide by 6828, and you're gone, and I rewrite 7697.01 all over 6828, and that's going to be equal to this 1 to the power plus r over 6 to the power of 36. We need to get rid of this power of 36 to untrap the parentheses. The way that we do that is we take both sides here to the power of 1 over 36. 1 over 36, and that will cancel some things out. You're gone, and I now have 1 plus r over 6 is equal to, copy paste time, woohoo, go. So grab you, copy, grab you, paste, and we're good. And then finally, what we're going to do is we are going to subtract 1 on both sides, so minus 1, and then after we subtract 1, we are going to undo divide by 6, which means that whole thing is going to be times 6, this entire thing times 6, and that will do the whole thing times 6. You're gone from the 1, you're gone from the 6, and I get r is equal to all of that thing. I know that I'm skipping a lot of steps, but I want to be done with this. All right, ready, set, calculator, go. That's a lot to type. I have 6 times the quantity of, holy moly, probably 2 quantities. I have on the inside 7697.01. That's going to be divided by 6828, and that first thing is going to be to the power of, and it's going to be a fraction. The top of the fraction is 1, the bottom of the fraction is 36, and then after that, then I subtract 1, and then we have the distribution in there. That looks to me like 0.02 if I round. So it's going to be with pen please, 0.02 after I round, and 0.02 as an interest rate is 2%. Last problem, let's go. I'm ready. All right, so we have a start amount, and we have an end amount. End amount is 12,078.76. Our start amount is 2675. It's going to be times 1 plus the interest rate, which we do have, 0.09, all over, compounding 3 times per year, so 3 and 3, and then time, which we don't have. That means we're needing a logarithm for this one. First things first, get rid of the 2675 by dividing by 2675 on both sides. You're gone and you're gone. So let's rewrite 12078.76 all over 2675. That's going to be equal to 1 plus, and I know what's about to happen, so I'm going to give some room, 1 plus 0.09 over 3, all this to the power of 3t. Time to untrap our Rapunzel by taking the logarithm of both sides. So I'm going to take log of this side and log of this side. Ooh, almost good timing. I'm almost done with this problem at the end of school. It's 3:14 right now. And what power or what base do I choose down here? Well, this base right here. So I have to rewrite this gigantic base of 1 plus 0.03 over 3, 0.09 over 3. 0.9 over 3, and this is going to be 1 plus 0.09 over 3. I could simplify that. It's 0.03, and then it would be 1.03, but whatever. I'm just going to make it nice and easy to plug in the calculator. You're gone, you're gone, you're gone. Leave me with a 3t, which is equal to, copy, paste down. There's a lot up there, right? Copy you, copy, paste is equal to all of you. And then finally, we have to get t by itself, so divide by 3. Divide by 3, enter that all in, I get t is equal to some amount of time that the calculator will tell me. That calculator will say, what? Don't know. Let's see if I can type it all in. And I have to do a change of base formula, so I apologize for not writing the change of base formula down, but here comes a gigantic function. The top of the change of base formula is 12078 divided by 2675. And because of the change of base formula, this is going to be divided by another logarithm, which is the base. And the base is 1 plus 0.09 divided by 3. Then I'll take that whole thing, divide by 3, which means just put another 3 down here. Boink. And I get 16.999, which is basically 17. So for here I get 17 years. Final answer. And box it. Have we been getting these right? 10, 2, 5, 6, 1, 2, and 17. 10, 2, 5, 6, 1, 2, 17. I mean, the last 4 are good, so I guess the other ones are hopefully good. And just again, there's a frame of all the answers to practice test number 3. That concludes this video. Thank you for watching. I'll talk to you guys later. Good luck on the test.